Today's most successful digital platforms are architected with APIs that expose core business capabilities for internal and external developers that build new applications at scale. Well-crafted APIs are more widely adopted by the developer community, giving their creators a competitive advantage in terms of innovation and new products. The key to developing successful APIs is using tools like Swagger to create better designs and documentation so that it is effortless for developers to use the API. Swagger helps you design, build, and document your APIs using a design-first approach so that web, mobile, and third-party applications can quickly integrate and consume their core capabilities and data. In this course, I'll show you how to build API definitions with the OpenAPI Specification that accelerate delivery of APIs through generated documentation, client SDKs, server stubs, and API server virtualization. We'll use Swagger's open-source tools to master key sections of the OpenAPI Specification. Then, we will advance to SwaggerHub and learn how its team collaboration tools streamline the API development lifecycle. To cap off the course, we'll complete a project that uses an API definition file to rapidly establish an API-based solution that spans multiple languages, frameworks, and cloud-based services. Before we dive into the course material, let's talk a little bit about who this course is for and what information you should know ahead of time. This course will benefit developers who would like to build or are building solutions centered around APIs. Developers will learn a design-first API approach to API development using Swagger. Swagger helps us design, build, and document APIs that are easier for clients to adopt and consume. It also helps us build APIs faster. In addition to API developers, consumers of APIs can benefit from the information provided regarding API documentation. This information found in the course makes it easier for API consumers to integrate with APIs documented using Swagger. In general, this course will provide insights into how APIs are designed, built, and documented. Additionally, you'll get a peek at some emerging technologies in the API space. By the end of the course, you will be better prepared to build systems architected with APIs. Finally, let's discuss what you should know in advance to get the most out of this course. The course will teach you how to work with Swagger and the OpenAPI specification, along with some other tools in the API space. The course should not be mistaken for an exhaustive course on every technology involved, such as REST, YAML, and JSON. You will be expected to understand these technologies prior to starting the course. The course project covers a lot of ground and it's pretty advanced, so you can choose to follow along in the final chapter or just observe as I walk you through the various technologies. Either way, you will take a lot of valuable information regarding APIs and tools in the API space away from the course. In the project, we build sample applications created with Angular and Spring. So if you choose to code along with me, understanding Java and Node.js is also helpful. If you understand these concepts, you'll do fine throughout the course, and I'll be there to guide you through every step. I'd like to give you a preview of the application we'll be building out in the final chapter of the course. So for the course project, we're going to build the H+ Sport product catalog application. This is an Angular application that receives its data and capabilities from the H+ Sport catalog API. So all the information that you see regarding the products within this page is provided by an API implementation that we designed and defined using Swagger and OAS. The API definition is created in SwaggerHub. So we defined the different operations on that API and described the different data that those operations expect and the data that they return to the API consumer. With that definition file, we were able to generate documentation. So this documentation is beneficial for any API consumer that's looking to invoke those operations on the API. We were also able to use SwaggerHub and our API definition file to generate two different components within the solutions architecture. So we built out a client SDK based upon TypeScript and Angular, and that client SDK is used within the Angular application to communicate with the API. The API implementation was created based upon a server stub that we generated through SwaggerHub using its generation capabilities for the Spring Framework. So we generated the server stub that uses the Spring Framework, and then we provided some additional implementation that served the data for the products and provided some additional capabilities that would allow you to create a product. Once we had that API implementation completed, we packaged it into a jar file, and we needed a place to host and run that API implementation, so we turned to Microsoft Azure. Within Microsoft Azure, we were able to provision a Linux VM, and we deployed our API implementation to it. We then ran that implementation on the VM, and we put DNS in front of the API implementation so that we had an easy way to send all of our traffic there. So here you can see some of the traffic that has gone to our API implementation. Once we had the implementation up and running on Azure with DNS, we turned to another tool, Google Apigee. So Google Apigee is an API management solution. So if you're an organization with a large catalog of APIs, Apigee can help you centralize the management of some API concerns. So things like security, throttling, and monitoring can be handled in a central solution that you proxy all of your API traffic through. So here you can see some of the capabilities provided by Apigee. It provides you with an area to develop and proxy APIs, and then you can also do things like monitor their performance, see some geomapping about where your traffic is coming from. So all sorts of great management tools for a catalog of APIs. So the key takeaway here is this entire solution was enabled by the API definition files that we created using Swagger's tools and the OpenAPI specification. It allowed us to quickly and efficiently deliver a solution that had high-quality documentation that would attract developers and promote high adoption rates. I'm excited to bring you this update, which adds 3 challenges and their solutions to the course. Over the course of these challenges, you'll build an API definition that describes operations on the H+ Sports Company blog using the OpenAPI specification. The exercise files for each challenge will build upon the work completed in the previous challenge. However, the exercise files will be separate from those in other lessons. In the first challenge, you'll create an API definition from scratch that retrieves blog posts from the API. In the next challenge, you'll define another operation that allows blog posts to be created on the API. Finally, we'll see how to publish the API on SwaggerHub and apply security to sensitive operations that it exposes. Hands-on experience is one of the best ways to learn, so I'm thrilled to bring you these challenges so you can hone your skills with Swagger and the OpenAPI specification. To kick things off, we'll discuss the overarching concepts that build the Swagger platform's foundation. To effectively use Swagger, you must understand the high-level difference between Swagger and the OpenAPI specification. It's a little confusing, and developers often have trouble understanding the difference. Swagger is a toolset and structured approach that helps us design, document, and generate code for RESTful APIs. The OpenAPI Specification provides a standard format for creating metadata that defines RESTful web services. Knowing the history behind these projects can help us better distinguish between the two. Swagger began in 2010 when Tony Tam started an open-source project to provide interactive API documentation and client SDKs for APIs at WordNik, an online dictionary service. At this point in its history, Swagger included both the specification and the tooling. The Swagger specification provided a structured approach for documenting APIs, and you will hear it referred to as OpenAPI Specification 2.0 or Swagger Docs. As time passed, Swagger gained popularity amongst several competing API description languages and was acquired by SmartBear in 2015. In order to keep the specification vendor neutral, SmartBear donated the Swagger specification to the OpenAPI initiative, who renamed it the OpenAPI Specification. The OpenAPI initiative is a collaborative working group focused on development of the OpenAPI Specification, which was formerly the Swagger specification. Members of the OpenAPI initiative include prominent organizations such as Microsoft, Google, IBM, PayPal, and SmartBear. So it's important to remember that Swagger allows us to easily design, document, and generate code for APIs. Swagger's toolset helps us produce API definitions that adhere to the OpenAPI standard. Other tools can read those definition files to build documentation, server stubs, and other client SDKs that are useful for working with APIs. On the other hand, the OpenAPI specification provides a standard format for metadata used to describe or define RESTful web services. The metadata is machine-readable so it can be consumed by tools or systems that are built to understand API definitions adhering to the standard. So at high level, think of Swagger as a set of tools and OAS as the rules for describing APIs. The Swagger toolbox can be broken down into two categories, the open source tools and pro tools. The open source tools are available to be downloaded and installed for free use. These tools provide the basics that you will need to build an API definition, API documentation, and client SDKs. The Pro tools provide a more comprehensive platform that includes collaboration features for teams that are building APIs. Additionally, you'll find the tools to build API definitions, generate code, and documentation within the Pro tools. The Pro tools are available via a subscription service which includes a free plan. So at a high level, this is an overview of the Swagger ecosystem. At the top level of the hierarchy, we need to distinguish between the Swagger toolset and the OpenAPI specification. The Swagger toolset is further categorized by the open source tools and the Pro tools. Throughout the course, we'll be diving into each of these areas so that you can build higher quality APIs in less time. Swagger's open source tools are a great way to design, document, and build definitions for RESTful web services. Let's take a closer look at these tools. There are three tools within the open source toolbox: the Swagger Editor, Swagger UI, and Swagger CodeGen. The editor acts like an IDE for building API definition files. Swagger UI can consume API definition files to produce interactive API documentation. Finally, Swagger CodeGen can build API clients or server stubs in several languages based off of the API definition files. The most important takeaway is that Swagger's tooling centers around API definition files that conform to the OpenAPI specification. On the Swagger website is a live demo of each of these tools. Let's take a closer look at the demos to get more familiar with the tooling. The first tool we'll look at is the Swagger Editor. You'll notice on the left side of the screen, we have the editor itself. It provides us with auto-completion features that we can use to quickly build out our API definitions. You'll also notice that as we update our API definition, the interactive documentation on the right-hand side will update with the changes that we've made. This allows us to quickly see the changes we make to our API definitions. Another nice feature of the editor is the fact that it can alert us to errors within our API definition. So you'll notice when we introduce an error, we get flagged on the right-hand side so that we can correct the issue. Think of the Swagger editor as a code editor, just like Eclipse or Visual Studio. However, this editor is specifically designed to build OAS-compliant API definition files. On the website, we can also get a preview of Swagger UI. Swagger UI hosts the API documentation generated from our API definition file. Here we see that Swagger has provided us with documentation for a fictional pet store API. On this documentation, we're able to see the endpoints or the operations exposed by the API. If we were a consumer or a client of this API, this is extremely valuable because we're able to dive into the different endpoints, see the request bodies that we need to send to the endpoint in order to invoke the operation, and then we're also able to see what responses are provided by the API. Another nice feature of the API documentation is that we have this try it out feature, which allows us to send calls against a mocked version of the API. The final tool we'll look at is Swagger Code Gen. You'll notice within the editor, we have these two menu options, Generate Server and Generate Client. If we take a look, you'll see many languages and frameworks that Swagger Code Gen supports. For each of these languages or frameworks, we're able to generate a client SDK for our API, or we can generate a server stub. So let's generate a Spring Framework server stub for our Pet Store API. Once we click on the option, you'll notice that the code downloads, and then if we inspect the zip file, we'll see the source code that we can use to build our API implementation. Throughout this course, we're going to be working with all three of these tools, and I'll teach you the tricks in order to be successful with them. When working with Swagger, understanding the purpose of the OpenAPI Specification, or OAS, can be one of the toughest concepts to grasp. However, it's critical to your success because Swagger tooling is centered around the OpenAPI Specification. I'm going to provide you with clear understanding on why OAS exists and its importance so that you can be successful with Swagger. Here is how the OpenAPI Specification describes itself within its own documentation. In a nutshell, OAS defines how we describe the interface of a RESTful API regardless of the language in which it's built. That's still a little abstract, so let's dive a little deeper. Here we see a rough description of a REST API interface. A REST API interface exposes endpoints or operations that clients can use to access API resources. So here we see an API with 3 endpoints that expose operations on a single resource named product. A client sends an HTTP call to invoke these operations on the API. Some of the API endpoints may require the client to provide data inputs in the request to properly invoke the operation. This is similar to how a method call may require arguments to be supplied. API endpoints can also send a response containing data for the client to consume, similar to how a method call can return an object. The key takeaway is that clients need information about the interface of the APIs they integrate with. At a minimum, they must know the available endpoints, what data to send to them, and what data they will receive from them. So we just saw a very simple API. Let's imagine that your coworker needs to call the REST API we just saw and they need your help. How would you describe the API or instruct them to call it? Now let's look at it from another perspective. Let's imagine that your coworker built the API and they need to tell you how to consume it. How might they describe the API? Let's say you both go with some metadata to describe the API to facilitate the other's interaction with it. It's a nice approach, but there's some inconsistencies. Because you haven't agreed upon a format or standards for describing the APIs, your definitions may be completely different. Now imagine if this API metadata needed to be consumed programmatically by a non-human client. How would it know how to consume each of these formats? What if another format came along? Wouldn't that just add to the confusion? This is where the OpenAPI specification comes into play. It provides us with a standard or rules that can be used to build definition files for an API so that both humans and computers can discover and understand the capabilities of a service. The API definition files conform to a standard, so no matter what our API looks like, it can be understood programmatically, allowing tools to help both humans and computers understand the API. Building OAS-compliant definition files for APIs has many benefits for developers. First, API definition files can be used to generate documentation, API-related code, or used for a bunch of other use cases like testing. This alleviates a large portion of the work for API developers and allows them to keep API documentation in sync with the implementation. Second, because the generated documentation provides examples, it is easier for consumers to integrate with your API. This results in a better developer experience and increases API usage. Finally, strong API documentation supports contract-first development, allowing development teams to work independently of each other because they have agreed to a well-defined interface that governs the interaction of systems and components. So that's OAS in a nutshell, and armed with this understanding, we can be successful throughout the rest of the course. In this lesson, we will install Swagger Editor and Swagger UI on our workstation so that we can start building API definitions and documentation. The code for the open source Swagger tools is available through Swagger's repositories on GitHub. On the Swagger page, we can find the Swagger UI repository. If we navigate into that repository, you'll see the Releases section, and inside of the Releases section, we can find the source code for Swagger UI. Let's go ahead and click on this link to download the source code. We're going to place the source code within a new directory on our desktop, and we're going to name that directory course_workspace. So go ahead and create the directory, and then save the zip file there. We're then going to head back to the Swagger API page and into the Swagger Editor repository. At this point, we can go to the Releases section, and just like Swagger UI, we can download that source code. So we'll put both of those into the course_workspace directory, and then let's navigate to that directory, and we can extract these zip files. Okay, and then if we take a peek in these extracted directories, you'll notice that Swagger nests the folders within each other. So let's just go ahead and we'll rename the directory Swagger Editor in this case, and then we'll cut that directory and place it within our course workspace directory, and then we're going to do the same thing for Swagger UI. So we'll cut that, put it within the course workspace directory, and then we can clean up these two empty directories. And now if we take a look, you'll see the source code for Swagger Editor, as well as the source code for Swagger UI. In order to run these tools, we're going to need a web server to host them. We can quickly install a web server using Node.js. So make sure Node is on your machine. If you don't have it, just go to nodejs.org and download the appropriate distribution for your workstation. Once you've downloaded Node.js, we need to install the HTTP server. So it's really simple with Node Package Manager. You just issue the npm command and then say install, and then the -G flag for globally, and then HTTP server. This will cause the Node Package Manager to install the HTTP server, and then we just run an npm install. And once that completes, we now have an HTTP server that we can use to host our Swagger tools locally. The first tool that will stand up is the Swagger editor. So we're just going to navigate into our course workspace directory, and then from here we're going to use the HTTP server command that we just installed, and we point to our Swagger editor directory, and then we're going to provide two flags. First is the -A flag, and we just provide our local IP, and this will restrict the tool to only being hosted on our workstation. And then we're going to specify a port of 8080. So now we see the HTTP servers up. We can then go to localhost 8080 on our machine, and here we see the Swagger editor is now available for us locally as a tool. We're going to now head into another command prompt and into the course workspace directory, where we're going to stand up Swagger UI. So much like Swagger editor, we use the HTTP server command, and then we're going to point to Swagger UI. We're going to specify our local IP, and then we're going to run this tool on port 8081 to avoid any port conflicts. There we see it's now stood up. So let's open up our browser to 8081. And then we need to navigate into the dist directory. And here we see Swagger UI running locally on our workstation. So with these tools up and running, we now have some local tools that we can use throughout the course to build API definition files. Before we go any further, I wanted to introduce you to H+ Sports. H+ Sports is a fictional company that provides products for an active lifestyle. We'll be using H+ Sports as an example throughout the lessons in this course. We will build API definition files that detail operations on an H+ Sports API that pertain to things like the company's product catalog, orders, and customers. In this lesson, we'll build our first API definition file that follows the standards set by the OpenAPI Specification. The API definition that we will build documents a product resource on the H+ Sports API. This resource allows API consumers to access the company's product catalog. The API operation is invoked by sending a GET request to the product endpoint. The API will respond to the request by returning an array of products found within the catalog. Our API definition is going to be very minimal, and we're only going to provide the required fields for the smallest possible API definition we can create. We can discover what fields or objects are necessary within that definition by visiting the OpenAPI Specification. So here we are at the OAS 3.0 specification, and if we navigate to the schema section, it will list the different sections of an OpenAPI definition. You'll notice that only 3 of these sections are required: the OpenAPI field, the info field, and the paths field. So let's get started with Swagger Editor in building out our API definition. The first thing that we're going to do is clear the editor, and then we're going to specify the OpenAPI field. And this simply indicates what version of OAS we're using, and that provides clues to Swagger Editor about how to perform our validations. Now, if we hit Control Space, we can access the auto-completion features of Swagger Editor, and we see the info field. This field allows us to provide metadata about the API itself, such as the title of the API. So we're going to say it's the H+ Sports API. And we can also specify things like the version, and we'll say it's version 1. So those things are pretty simple. We're now going to take a look at the paths field, which is probably the most important field on an API definition because it allows us to specify the resources or operations exposed by the APIs. In a nutshell, it's really the API's capabilities. To do that, we first specify a path object. So in this case, we're going to be exposing the product endpoint. Within that product endpoint, we're going to expose the get operation, which corresponds to the HTTP method that will be used to invoke this operation. You'll notice that we're using YAML, so it's important to indent two spaces when we have different fields on an object. So we'll navigate to the next line, indent two spaces, and now we're able to specify the responses. So this is indicating what data the API is going to return from this endpoint or operation. The first thing we provide within the responses object is the HTTP status code. From there, we can provide a description of this operation. So we'll say this is a list of the products in the catalog. And then from here, we can go on to describe the response body that will be returned. So we use the content field in order to do that. And within the content field, we specify the media type. In this case, we're going to be returning JSON. And then there's a schema field nested within that. The schema field allows us to describe kind of the data format or data type that we'll be returning. So we're able to indicate what the objects look like that we'll be returning, specifying constraints and other things that describe the data coming back in the response body. So to start out, we're going to say that the type of data we're returning is an array, and then we're able to specify what the items in that array look like by describing the properties on that item. So in this case, we're going to have an ID for our product, and then nested within the ID object, we're able to specify the data type of this property. And then we can go ahead and provide an example of what this data might look like. Now we're also going to have a name for our product object, and that's going to be of type string. And then we can provide a simple example. We'll just say it's going to be lemon water. And that's it. We have a valid OpenAPI Specification 3.0 API definition. You'll notice on the right-hand side, our interactive documentation allows us to see the details of this operation on the API, and this could be used by any API consumer to learn how to invoke this operation. It's time for the first challenge, where you will build a definition file for the API that powers the H+ Sport Company's blog. To complete the challenge, you must create a new API definition file that exposes a single path used to access an array of articles. The array returned by the endpoint is used to populate the list of articles found on the front page of the blog. Before you dive in, let me give you a hint. Start out by inspecting the H+ Sport blog to determine the properties required for an article schema object. At a quick glance, I would recommend adding properties for the created date, tagline, content, category, and tags. This challenge should take you about 10 minutes to complete. In the next video, I'll show you how I solved the challenge. Good luck! Let's take a look at one way to complete the challenge. To begin building an API definition, we need to specify three required fields. The first is the OpenAPI field, where we specify the version of the OAS specification that we'll be using. In our case, that's version 3. Next is the info field. Within the info field, we can specify the version of the API as well as a title for it. In this case, it's going to be the H plus blog API. And then finally, we're able to specify the paths on the API definition. Within the paths field, we're going to go ahead and specify an article path that's going to be used to retrieve articles from the API. Because we're retrieving resources, it's appropriate to use the get operation, so we'll specify that underneath this path. Next, we'll describe the operation's response and the content it returns. In this case, we'd like to describe the 200 HTTP response that's going to return an array of articles in JSON format. So underneath the HTTP status code, we'll first add a description. We'll say it's a page of articles. And then we're going to go ahead and describe the content itself. In this case, it's going to be in JSON format, so we can go ahead and specify the MIME type. The next field is the schema object that defines the response body returned by the operation. This is where the actual data or content is described, which in this case is an array of article objects. So we'll go ahead and specify the type as array, and then we'll need to describe the items within that array and their data type, which will be of type object. The article object will contain properties whose values describe the article. So we're going to now add those properties within the properties field. The first will be the created date property. And here we're going to specify that its type is a string, but then we'll specify that the format is a date. Next, we're going to add the tagline, which will also be a string. We'll follow that with the content of the actual article, which will be of type string. And then we'll specify the category, which will be of type string. And then finally, we're going to add the tags property, which is going to be an array, so we also need to describe the items in the array and their data type. Finally, to tidy things up, we're going to add tags to our operation so it can be grouped under the article resource. So right before the paths, I'm going to go ahead and add the tags field. And we can specify our first tag and its name, which is going to be article. And then we can give a description of that tag. We can say articles for the H plus sport blog. After we've defined the tag, we can then add it to the operation using the tags field underneath the get operation. Here, I'll just specify that we'd like to use the article tag, and you'll notice that it shows up within our documentation. We can also take a look at the endpoint that we just created, and we can see the article response from our operation. That completes our solution for the challenge, which should have made you more comfortable using YAML, OAS, and the Swagger editor to build an API definition. We took a small peek at the OpenAPI specification. However, there are many additional objects within the spec that can be used to create API definitions. Let's take a high-level look at the specification to explore these new objects. OAS-compliant definition files may contain 7 sections at the root level. Within these 7 objects, we can nest additional properties to build a definition for an API. OAS definitions can be built with either YAML or JSON. However, in this course, we will use YAML because it is the most common markup you will encounter when using Swagger. Of these initial sections, only the info and paths object are required. However, the paths and components objects are arguably the two most important within an API definition. We'll do most of the work within these sections throughout the course. We've had a glimpse at the info object. It contains general API information such as a name and description for the API. It also allows us to provide other details like the developer's contact information and a link to the license for the API. The server's object can identify the URL and a description of the servers hosting the API. This can be very useful for tagging development servers. Often, we'll provide URLs to the multiple environments that are hosting our API implementations, such as URLs to the dev, UAT, and production instances of our API. The security object allows you to describe how the API is secured by specifying information regarding API keys, OAuth flows, or security cookies. When consumers of the API definition read this section, they will understand what is required from an authentication and authorization perspective for access to API resources. Within the paths object, we can specify multiple paths or endpoints that describe how to access resources on the API. The paths object probably requires the most information of all sections of the spec because we describe the incoming and outgoing data requirements in detail. Using the tags object, we can define tags that can be used to group API operations. The external doc section allows us to provide links to external resources about the API that are hosted elsewhere. Finally, the components object allows you to define common schema objects, parameters, request bodies, and responses that may be used throughout the API. This section creates the ability to reuse components as opposed to repeating the same definitions over and over. Without this reusability, API definitions would be much harder to manage. So that is a glimpse of the OpenAPI specification at the top level. We'll dive into the details for most of these sections so you can build your API definition files to suit your needs. Throughout this chapter, we're going to cover the most commonly used parts of the OpenAPI specification. Unfortunately, we can't cover every part of the specification because it's not worth your time. There's going to be a lot of sections you may never use. So what we're going to do is take a few minutes to look at how to read the specification. That way, when you're on your own after this course, if you encounter an edge case or an obscure part of the spec you need to use, you know how to find the information you need. So on the OpenAPI Initiative's GitHub page, you're going to find a repository, the OpenAPI Specification repository, that holds the spec. Within the versions section of this repository, you'll find the various versions of the spec that we can take a look at to learn how to build API definitions. We'll take a look at version 3.0. The first thing you'll see as you scroll down the specification is a table of contents, and within this table of contents we can navigate to different sections of the spec. You'll find that you can get information on things like data types, different formats, the document structure, but really the most important section is the schema section. This is going to define those root objects within the OAS specification that we can then further define by specifying their nested fields. So here we see the 7 or so sections, and let's just navigate into the paths object by using the hyperlink in the type. So here we're going to drop down another level within the spec, and we're looking at a paths object. So you'll notice this is a patterned field. So what that means is it's not a fixed field where the property that we type in the spec is going to be the same every time. Instead, it's going to be a variable path. So for example, we see several examples of the API definition here, and this is a path item object, And that can change depending upon the API, so it's not static. Something like this get property is going to be fixed because we're always going to use either get, post, some sort of API operation we'll define there. So if we drill down into the path item object, here we see the fields that can be nested within that object. And you'll notice here we see those operations that we just talked about. So there's the get, the put, the post, delete, all the different operations that pretty much correspond with HTTP methods that can be used to invoke the different endpoints or operations on our API. Let's drill down into the get operation, and here we see the various fields that can be nested within that object. So we can see that we can provide a parameters field, we can provide a request body, we can also provide responses. In fact, the responses are the only required object within this object. So let's drill down into the responses object, and you'll notice that it has a patterned field that is the HTTP status code. So this is going to correspond with the various status codes provided by the HTTP specification. So things like 200s for successes, 404s for resources that can't be found. Those sorts of things make it a pattern field because it will never really be fixed. And then if we navigate into that response object, you can see the fields available here, and probably the most important one is this content field. It's a fixed field that is the media type of the object. So this is going to be something like application JSON, application XML. Normally it's JSON. Once again, you can see examples within the specification itself if you ever need help. So let's drill down one more level and talk about the schema object. The schema object is extremely important. We'll use it quite a bit because it's used to define the inputs and outputs and describe the data associated with them. So it's really defining what data an API consumer must provide to an API operation, or what data a consumer can expect to receive from an API operation. You can kind of get the pattern of reading the spec. You keep drilling down into these nested fields within these objects in order to learn how to craft your API definition. As we work throughout the course, we're going to leverage a large portion of the specification, but if you do run into an edge case, now you know how to read the spec. In this lesson, we'll learn how to describe query parameters within an API definition. In the first demonstration, we built a simple endpoint that listed all the products available in the H+ Sports catalog. It did not require API clients to provide additional data, which isn't the case for most API operations. Let's enhance that operation to accept two additional query parameters, page size and page number, that introduce a paging capability into the API. We'll introduce the new parameters using Swagger Editor. When we describe parameters for an API definition, we place them underneath the operation. So I'm going to create a new line below get, and here I can rely upon the auto-completion to specify the parameters object. Now inside of the parameters object, we can provide an array of parameters. The way we do that is by specifying a dash nested two spaces within the parameters object. Then we use the in property to define the type of parameter. You'll see that we have several options: query, header, path, and cookie. In this case, we want to use the query option, and this means that the parameter is going to be provided within the query string. Once we've specified the type of the parameter, we then go ahead and specify its name. So the name of our first parameter is going to be page number, and then we can go ahead and provide a description of this parameter. So we can say it's the page number to return, and then we specify whether or not it's required. In this case, we're not going to require the parameter to be supplied when the operation is invoked. Then we can provide the schema, which outlines what the data type looks like that our API expects to consume. In this case, it's going to expect a simple integer, and we can give an example of what that integer looks like. We're then going to add another item to this array for the second query parameter. And this query parameter is going to have a name of page size, and its description is going to state that it is the number of results in the page. And then we can go ahead and specify that it is not required using the required property. And then finally, we can describe the type of data we expect to consume. It's going to be an integer. And then we can provide an example of that data. Let's say that it's going to be 10. And then another thing that we can look at is the various constraints that we can place on this parameter. So we can set something like a minimum, a maximum, a max length. You can even provide a pattern here in order to constrain the type of data provided. Let's just go ahead and specify that they can only request a maximum of 100 items within the page. If we look at our interactive API documentation, you'll now see that these two parameters are contained within the documentation for this API operation. In this lesson, we'll learn how to describe template parameters within an API definition. REST APIs often require template parameters or path variables to be supplied in the path of an endpoint. This helps us identify a specific resource instance in most cases. Template parameters are a section of the URL that is a variable or replaceable parameter. Let's add a new product endpoint to the H+ Sport API that captures a product ID within its path. That product ID can then be used by the API implementation to return a specific product to the API client. To get started, we're going to create a new path within our paths object. This new path /product/ is going to include curly braces to denote the template parameter within the path. The curly braces indicate that the product ID is a replaceable section of our path. Now that we've defined the path, all we need to do is add the operation, and then we can add in our parameters for this operation. So we specify the parameters within a YAML array, and this time we're going to go ahead and select the path option for our in property. Now we supply a name of our template parameter that matches the path we've specified above, and then anytime we have a template parameter, they're going to be required, so we set required to true, and then we define the type of data using the schema and our data type. And then, as always, we can provide some sort of example. And then anytime we have an operation, we know that the responses object is required. And since we've already defined a 200 response, we're going to borrow from our other operation, and we'll just come up and provide that response. Now, in this case, we're not going to be returning an array, so we'll have to do some modification here. Instead of our type being array, we simply set that to object, and that denotes that we're only going to be returning one object. And that means we can get rid of our items property. And here we just fix the indentation within our YAML markup. And now we've defined our new API operation that leverages the template parameter that we've defined within the path. In addition to path variables, we can also specify that a request header or cookie is expected to be sent to an endpoint by changing the in property. So if we add another parameter to our operation, we can specify that we would like a header to be provided with each request. So let's say that we're putting some sort of custom security header in place for our requests, and let's say that it's not required. That's only in certain cases. And then what we can do is specify the schema for this header parameter by specifying its type and then giving another example. So here we see another type of parameter, a header parameter, that can be provided. And if we now inspect our new API operation, you'll see that our product ID, which is our template parameter, is required, and our header parameter is marked as optional. You'll also notice that we get an example of the response that is returned by this API operation. In this lesson, we'll learn how to describe request bodies for post operations to an API. When API clients must create or update a resource, they send data to an API using an HTTP post or put operation with the new data placed in the body of the request. Let's create a post operation within the product endpoint that allows a client to create a new product by passing the product data to the API operation in the request body. Within our API definition file, we already have a product endpoint. Within that path, we're simply going to add a new operation of type post. Inside the post operation, we can add a description so that API consumers can understand when to use this operation. So we can say add a product to the catalog, and that's what we will use this operation for. And the next thing we'll do is describe the request body for this operation. So we're going to describe the data that the API client must send in order to create a new product. It's very similar to some of the definition that we saw within the responses object. We have the content object once again, and then we supply the media type of the data being provided. In this case, we're using JSON, and then we're going to specify the schema object, and then we're able to tell our API consumers that we would like them to provide a single object, and then we define the properties of that object. Now, we're just going to copy the properties from our previous product object that we defined, and what we can do is put that in place within our API definition, and we'll need to do a little bit of indenting. And at this point, we have specified our request body, so our API clients know the data to provide to us, but we haven't described a response at this point. So the responses are in line with the request body. You can use the helpful lines within the editor to better understand where these objects go within your YAML file. And then inside of the response, we can provide the HTTP status code of 200. So on a successful response, we're going to return a 200, and we'll just say the product has been created. And at this point, we've satisfied all of the requirements of the OAS specification. And you can see on our API documentation, we now have a product endpoint that is accessible via a post operation, and we define the request body that an API client would need to provide in order to create a new product in the H+ Sport catalog. When building API definitions, some objects such as schemas or parameters may be found within more than one operation definition. Just like programming, it's important to keep it dry, meaning do not repeat yourself. To enforce this best practice, the OpenAPI specification provides us with a way to reuse certain objects by making them reusable components within our API definition file. Let's look at our API. We find at least 3 instances where we define a data structure representing a product. One within the get operation for product, one within the post operation for product, and then one within our endpoint containing the template parameter. It would be very helpful if we could reuse a data structure for this product, and that's what we're going to take a look at within this lesson. To begin, we're going to navigate to the bottom of our API definition file, and then using auto-completion, we're going to look for the components object. And then within that components object, we're able to specify the schemas object, and here we can use a name for our object we'd like to create, in this case, product. Within the product, we need to specify what this data structure or this reusable object is going to look like. So we have a really good idea because we've defined this multiple times. So we know it is an object that has a name and ID property. So what I'm going to do is just copy this definition from our API definition file and then paste it within the product object inside of our components section. And then, of course, I need to line up this YAML to make sure it's valid. And once that's complete, we'll have a valid API definition. Now we have this product object that we can refer to throughout our API. So let's scroll up, and here we see that we are defining a product. So at this point, we can remove this explicit definition of our schema, and we'll get introduced to a new property, and it's the $ref property. And once we've selected that property, just hit Control Space and start typing product. And then you can select the product that we defined within our component section. You'll notice there's a path pointing to that product. The hash at the beginning of this path specifies it's within the current file. So what we can do is just copy this, and then we're going to go to the other areas of our API definition where we have defined this product object. And here we can once again introduce the reference, and then we start to type product, we get auto-completion, and we can specify that path to our component. And then finally, we'll put it within our get operation here. So we're going to go ahead, and this time we need to be within the items object. So here we can specify a reference to our product, and that will satisfy our API definition file. Looks like we have an extra space there. Let's clean that up. Okay, So now if we look at our documentation, you can see we still have the same old product described for each of these operations. Now here is the beautiful part. If we need to add additional properties to this product, we only need to do it in one spot. So here I'm adding a description for our product, and then I'm going to provide an example. And you will notice that each of our operations is now updated with our new property for our product object. So let's go ahead and we're going to add in 2 more additional properties here that will be used by our API. The first that we're going to add is the image title. So we're going to be able to provide some sort of image via this API, and the image title is going to be a string. And just as an example, we're going to say that it's mineral water, lemon, lime. And then we can add another property, and this property is going to be the image itself. And here we're going to create a hyperlink to the actual image. And we'll just make up a fictional URL here to where that image resides. Now, another neat thing that we can do within the component section is define some validations for our different objects that we create. So here you can see the required property, and within that property, we can specify an array of required fields on this object. So here we're saying that the name property is required anytime that we specify a product object. And if we take a look at the schemas defined within our documentation that our API consumers can see, you'll notice that name gets the required indicator. So when a schema or object appears over and over again within your API definitions, look to move it to the components section so that you can achieve that reusability and make your API definition files much more maintainable. The components section of an API definition can include objects other than schemas. Using the auto-completion feature, we can take a look at the available objects that we can define as reusable components. You'll notice that we're able to specify request bodies, headers, and responses. Let's go ahead and build out a standard response for errors that may occur within our API operations. You'll notice that we could define these errors within each operation themselves by putting a status code underneath the operation and then building out our error message. Instead, we're going to create the response within the components section for reusability. The first thing we'll need to do under the response object is name our new response. In this case, we're going to create a response named 500 API error. And then we'll go ahead and underneath that object, we'll define what it looks like. The first thing we'll do is provide a description. So we'll say this is an unexpected error. And then we'll go ahead and describe what the actual data returned to the API client will look like. So we can specify the content object, and within that, we can still specify a media type. We're going to be using JSON once again, and then we start to define that schema object. So underneath the schema object, we specify the type of the data we're going to return. In this case, it's going to be an object, and that object's going to contain 2 properties. One being a status code, which is of type string. So we can specify an example of the status code here. So we'll say it is a 500. And then we can provide a message that will be returned to the API client. This is also going to be of type string, and we'll just provide something really generic like this is an error. Okay, now that we have our 500 API error described, we can reuse it across our API definitions. So what we'll do is within each of our operations, we can specify a 500 status code as a response, and then we use the ref property to refer to the 500 API error. So I'm just going to go ahead and copy this, and then navigate to our next API operation. Within here, I'll specify what we return in the event of a 500, and then we will add our final 500 status code to our last API operation. Now, if we take a look at our documentation that was built, we will now see the 500 response defined within each of our operations. So there is the 500 error that will return. This is a great way to achieve a standard error response across the APIs that you build for your organization. Query parameters are another object that can be reused in API definition files. If we take a look at our API definition, we'll see within our product endpoint that we have the paging parameters that we established for the get operation. These parameters could easily be reused for other endpoints that require paging. So let's go ahead and copy these because we're going to move them within the components section to make them reusable. To do that, we simply add the parameters object to the component section, and then we need to provide a name for each of the parameters that we want to define. So in this case, I'm going to supply a parameter named page number, and then we're going to grab the YAML that defines these parameters and paste it in, and then we simply adjust the indentation to conform to YAML standards. And then we'll need to build out our second parameter, which is going to be the page size. And here we'll once again need to do some indentation. And once that's in place, we'll have a valid API definition. And we can now take our two parameters and put them within the get operation for our product endpoint. So to do that, we need to structure our definition a little bit differently. So instead of explicitly defining these parameters here, we're going to remove the definition, and then we're going to add an array of references. And in this case, we're going to point to the page number, and then we're going to add another reference within that array to our page size component. Okay, now if we take a look at our product endpoint and the get operation, we can see the page number and page size parameters, which are supplied by the parameters defined in our component section. In this lesson, we'll learn how to use content negotiation to define different response formats for API operations. Currently, we've defined all of our API responses in a JSON format. Sometimes you'll need to use other formats like XML. With the introduction of content negotiation in OAS 3.0, we have the ability to accept or provide multiple media types for our API operations. Let's leverage this new feature by providing an XML response from our product endpoint that uses a template parameter. You'll see how extremely simple this is once we work through our example. You'll notice that we have our product endpoint using the template parameter, and within this operation, we have defined our JSON response. All we need to do is specify a second media type right in line with the first, and in this case, it's going to be application/XML. And then we just specify the schema object, and we point to our reusable product component. And at this point, if we take a look at our API documentation, here we see the product/template parameter product ID endpoint. And within this get operation, we can inspect the responses. You'll notice there's a drop-down. And the first option in the drop-down is the JSON media type. But we can now switch to the XML media type, and we're able to see a response in XML format. So the addition of content negotiation allows us to easily describe other response formats within our API documentation. This can be very handy when dealing with legacy services that may provide XML responses. Now, we're not going to be using XML throughout the remainder of the course, so I am going to go ahead and remove this definition before proceeding. But if your API requires it, you now know how to use XML through the content negotiation feature. Once we've built an API definition file, we can automatically generate interactive documentation from the file using Swagger UI. To get started, we just need to save our API definition from Swagger Editor. To do this, we click on the File option within the menu and then click on Save as YAML. This is going to open a dialog where we can then save our API definition file. In this case, we're going to save the file within our course workspace directory on the desktop. I'm going to go ahead and name the file hsports-api.yaml. Once the file has downloaded, we can navigate to the directory containing the file, and we're going to copy our API definition. From there, we're going to navigate into the Swagger-UI directory where we find the Swagger installation. In this directory, you'll see the dist directory. Let's navigate into that directory and then paste our API definition file. Now, if we hop up a directory, we can copy dist, and then we can paste dist within the course workspace directory. At this point, I'm going to go ahead and change the name of that directory to API-docs. Then there's one final change that we need to make. Inside the API docs directory, you'll see the index.html file. Within this file, if we open it in a text editor, you're going to see that it points to an API definition. So here we see that it's pointing to the pet store API definition that's hosted on Swagger's website. We simply need to change this line to point at our own API definition file that sits within our API docs directory. So just go ahead and change that to hsports-api.yaml and then save the file and we can close it. At this point, we just need to start our HTTP server to serve our API docs directory. So I'm going to open this command line, and within the command line, I can use the http-server command, and then I point to the API docs directory to serve it, and then I'll provide our local IP followed by the port. In this case, it'll be 8081. And if we issue that command, we see the HTTP server start up Swagger UI. And now we can navigate to a browser and access our Swagger UI installation on port 8081 on the local host. And there we see our first API definition file hosted within Swagger UI. You'll notice that we get the interactive documentation provided by Swagger UI, and we're able to see these descriptions of our REST API operations. And this is extremely valuable for any API client looking to use our API implementation. It's time for another challenge. Let's pick up where we left off in the last challenge and add some new capabilities to the blog API definition. The new capability will expose an operation on the article path that allows a new article to be created. To complete the challenge, expand the API definition file to include the appropriate HTTP operation for the capability. Within the operation, you should define a JSON-based request body that is used to create the article. Additionally, the operation should return a simple response that contains the appropriate HTTP status code for creating a resource on a REST API. If you want to make this challenge a little easier, think about how you could reuse some of the existing YAML in your API definition. This challenge should take you about 10 minutes to complete. In the next video, I'll show you how I solved it. Good luck! In this video, I'll share my solution for this challenge. To get started, I'm going to add a component section to the bottom of the file. Within this component section, I'm going to create a reusable schema object that represents the article resource. This component will provide us with some reusability throughout the API definition, and we can avoid repeating the article schema object throughout the file. To define the properties on the article schema object, we can go ahead and copy the properties from the object on our get operation. So I'm just going to go ahead and copy these fields and place them within the article schema object at the bottom of the file. Once they're in place, I can go ahead and click on Edit and then Convert to YAML, and the file will automatically format. Now we can just go ahead and remove those properties from the API definition underneath the get operation. We'll still need to specify the type of the objects in the array for the get operation, so we can now use our new component by using the ref property and then pointing to the article component that we just created. Okay, so now we have our reusable schema object, and we can begin to create our next operation on the API definition. If you chose the post operation to add to the article path, you chose the correct operation for creating a resource on a REST API. So with the post operation added, we're going to also add the tags field, and we're going to create this operation underneath the article tag so we can nest it within that resource. The next thing that we'll need to do is specify the request body that will be accepted by this operation. Underneath the request body field, we can go ahead and add the content field. Then we can specify the MIME type as application JSON. And then here we just provide the schema for the object that we would like to receive as the request body. Once again, we can go ahead and use the ref field and point to the article schema object that we just created. There's only one thing left to do. We need to return a response from this operation. So let's go ahead, we'll add the responses field, and then when we create a new resource on a REST API, we should use a 201 status code to indicate that that resource has been created. So I'll add the HTTP status code, and then nested within it, I can provide a description, and we'll just say that the article has been created. That completes the solution for this challenge, which should have given you additional experience defining REST API operations. In this chapter, we will shift our focus to SwaggerHub. SwaggerHub is a cloud-based development platform for API design and documentation with OpenAPI. Inside the platform, you will find advanced capabilities that surround the open source tools we discussed in the last chapter. If you're familiar with the open source tools, you will easily transition to using SwaggerHub. The capabilities within SwaggerHub extend or complement those provided by the open source tooling. Many of these capabilities support how teams collaborate to build and consume APIs. This is more challenging than building APIs in isolation because concerns such as reuse and standardization become more difficult. SwaggerHub has a feature called domains. This feature allows object definitions to be reused across API definitions. Additionally, SwaggerHub provides a number of management features surrounding API definitions, such as access restrictions, versioning, and integration with source control like Git. These capabilities allow organizations and teams to secure their API projects and share them selectively with other collaborators. SwaggerHub also contains features that speed up development, such as mocking and virtualization, allowing APIs to be consumed before an implementation is completed. Finally, the editor within SwaggerHub provides rich features such as better auto-completion, customizations, and validation. For organizations with large API catalogs, the features provided by SwaggerHub are extremely beneficial. The platform increases consistency across APIs by delivering reusable components and validation, making API adoption easier for developers. Similar to version control, it provides an organized approach to building and releasing APIs across their lifecycle, removing the barriers that prohibit teams from collaborating. Finally, API-based development can occur more rapidly because of the capabilities in SwaggerHub. The ability to quickly define an API and mock it allows API developers and consumers to work in parallel. After finishing this chapter, you will understand how to leverage these SwaggerHub features to take your API development to the next level. In this lesson, we're going to sign up for a SwaggerHub account so that we can start building API definitions within the platform. So on the SwaggerHub website, you're going to see the option to sign up for free. So if we click on that, it allows us to register for a 14-day trial. You can sign in with your GitHub account, or you can create a new user account. That's the route I'm going to go. So let's create the H+ Sport user, and then I'm going to use a Gmail address that I have, and then specify a password for the account. Once we've provided all those details, go ahead and hit sign up. Then it's going to ask us for the name of our organization. So let's go ahead and specify that this is the H+ Sport organization, and then it's asking us for a phone number. So we can just make up a phone number here, and we should be good to go. So I'm going to go ahead then and click on the Continue to My Account button. And at this point, it's going to ask us to invite collaborators. So if you had team members that were going to help you work on your API definitions, now's the point where you would invite them. I'm not working with anybody, so I'm just going to continue to my account. And then it's going to build out our account, and you'll notice we are prompted to either create or import a new API. We're going to actually create an API, and this is going to open a dialog box where we can provide some high-level metadata about the API definition we'd like to create. Now, one thing that's very important is make sure you're always choosing OpenAPI version 3.0 throughout the course. The next option we have is to specify a template. So this is kind of a Kickstarter for us to get started building our API definitions. And we're going to use the simple API template. And the next item is the name of the API definition, which we're going to specify as customer. You'll notice that our H+ Sport organization is specified as the owning organization of this API definition, and the visibility set to private, as well as the auto mocking features enabled. So with these configuration options selected, let's go ahead and create the API. And then Swagger's going to start building it, and it launches us right into this editor section of SwaggerHub. So on the left-hand side, you'll see that we can navigate through the different operations within our API definition file. And then in the center, we have the editor, which actually has the API definition. And then on the right, we have the interactive API documentation. Now, in SwaggerHub, we are also able to customize some of the settings in the editor. So I'm going to switch this over to the light mode and then increase the font size. On the left-hand side, you'll notice that we can hide or show different areas of the screen. So for example, if I wanted to hide the navigation, I can click on this little compass here, and now we have a wider editor. So this is how I'm going to leave the editor set up throughout the course so you have a better view of the work we're doing. At this point, we've configured our Swagger editor within the SwaggerHub platform, and we're ready to get started building out our APIs. SwaggerHub's templates can give us a jump start on building API definitions. In the last lesson, we built a customer API from the simple template. Now we'll customize the customer API definition to suit the needs of H+ Sport. So to get started, we're going to navigate to the bottom of our API definition, and here you'll find two different schema objects. One is the inventory item, and the other is the manufacturer. We're not going to use the manufacturer, so let's go ahead and remove it. And now we're going to customize the inventory item to actually be a customer schema. We can leave its type as object, and then we're going to remove the ID property from the required field list, and then we'll add a customer number to the required field list, and then remove the release date. At this point, we can adjust the properties within this object. So we'll add the customer number. We'll leave it as a type string, but remove this UUID format. And then we can just shorten the example so that we have a more concise customer number. We can leave the name property, but we'll switch the example over to an actual customer name. So we'll just go with John Smith there. And then we're going to switch the release date over to a phone number. We'll keep it of type string, but we will remove the format and modify the example to a very simple phone number. Okay, and then at this point we can remove the manufacturer field. So we have a customer schema defined within our component section, and we can now navigate to the top of the API definition to start making some additional changes. You'll notice that we have the servers object, which points to SwaggerHub's auto-mocking capabilities. We'll leave that in place for now. But we do want to change the description within the info object. So we can say this is an API for H+ Sport customers. And then we'll change the title of our API to the customers API. And here within the contact information, we'll switch the email address over to the H+ Sport domain. We can leave the license as the Apache license. And then moving on to the tags object, here we're able to specify tags that can be used to group different operations within our API definitions. So I'm going to create a customer tag, and we'll update the description to customer related calls, and then we can go ahead and remove this developers tag. Okay, and now to the important section, the paths object. Within the paths object, we're going to replace the inventory path with a customer path. And we'll update the tag for the get operation to be the customer tag. And then some of this summary and description information, we'll just switch it over to indicate it's actually for our customer. Okay. And we can say that we're able to search available customers in the system. And then within this operation, we're not going to use any of these parameters specified in the template. So I'll just go ahead and remove those. And now we can update the 200 response to return an array of customer objects. So we'll go ahead and reference the customer within our components section. And then the final thing that we're going to do is remove the post operation because we'll no longer be performing a post within this API. Okay, so now we can see at the bottom of the screen, it indicates that our API definition is valid. So let's actually go ahead and save our API definition at this point, and we can hop out of the API definition by going back to My Hub, which is kind of your home screen in SwaggerHub. You'll notice on the left-hand side of SwaggerHub, we have this sidebar navigation. Here you'll see our organization. And then here in the main content area, we're able to see all of the APIs that we have access to. So there sits our customer API. We can navigate back into that API. And here we see the interactive API documentation for our newly formed customer API definition, which we were able to build from a simple template. You saw how quickly the template allowed us to springboard into API development. The ability to manage multiple versions of an API definition is an important SwaggerHub feature because it prevents us from breaking systems that consume our APIs. SwaggerHub allows us to strategically version our API definitions throughout their lifecycle, which helps us to deprecate old versions that can carry large maintenance burdens. To get started, let's publish the first version of the customer API. Publishing is performed when an API is deemed ready for production use. To do that, we simply click on the version number at the top of our editor screen, and then you'll notice we have the option to publish this API. If we click on that option, you'll see that we can select the visibility of the API. In this case, I'm going to flip it over to public, and then we can publish the version. At this point, our API is now exposed for public consumption, and it's version 1. Now, what you'll notice is if you go back to the editor, we can no longer edit this API definition. So I'm trying to make changes here, and it just won't allow it. That's because we should not change published versions of an API definition. This can cause our API consumers to experience breaking changes. So SwaggerHub protects us by providing the ability to version our APIs and by preventing us from modifying published versions of an API. But let's say we do need to make a change. We're ready to release our new and improved customer API. What we can do is come up to this versions option within the editor and click on Add New Version. At that point, we have to specify the version number. So you'll notice there's a standard that must be applied for this numbering convention. So we're going to use 2.0.0, and then we can specify whether or not we would like it to be visible to the public or whether we would like it to be private. Since we're just working on this, I'm going to set it to private so that it's not publicly exposed for external consumption. We can then go ahead and create this new version, and you'll now notice that if we'd like to make a change, we can go ahead and do that because it hasn't been published yet. So let's make some enhancements to our API definition. You'll notice that we have the name property, and it's really not a good idea to have the first and last name in the same field. So let's change this over to first name, and we'll make that John. And then we're going to add a last name property of type string. And for the example, we can specify that it's John Smith. And then here, we'll need to update our required properties. So we can switch that over to first name and then last name. And at this point, our API definition should be valid, and we will be able to see the changes within our interactive API documentation, including our schema section, which defines these two new required properties. Okay, so our changes have been made. Let's go ahead and save them. So at this point, they are saved within SwaggerHub, and we're ready to publish this new API version. So all we have to do is click on Publish API, and I think it's ready for prime time. So let's open it up outside of our organization. So we'll switch it over to public and then click on Publish Version. Okay, so at this point, we now have two versions of our API. When we have multiple versions of an API, SwaggerHub provides an extremely nice feature. Here you'll see the Compare Versions tool that's located underneath the version number within the editor. Within this tool, we see a diff of the two different API versions so that we can easily see what's different between them. You'll also notice that SwaggerHub has automatically updated the version of our new API definition. And if we would like, we can go ahead and apply changes within this diff tool. Now, I'm not going to revert back to our first version, so I'll go ahead and undo this option and then cancel out. So in this lesson, we saw how to publish versions of our API definitions and how to diff them to see changes. In some situations, you may need to import an existing OAS API definition file into SwaggerHub. So, for example, we've worked within Swagger Editor to build out the catalog API definition for H Sports. Let's say that we're really happy with Swagger Editor, but we'd like to graduate to the collaboration features that we've discovered within SwaggerHub. All we need to do is click on File and then go to Save as YAML, and then within our course workspace directory, I'm going to name this YAML file hsports-api.yaml. So I'll go ahead and save that, and now we can navigate over to SwaggerHub, and you'll see the Create New option within the left-hand sidebar. Here, we can select the Import and Document API menu item, and it allows us via this dialog to browse for an API definition. In this case, we're going to grab our newly created hsports-api.yaml file, and then we can select the organization and the visibility. So I'm going to leave that as H plus Sport and private. And then we just click on Upload the file, and then we can import the OpenAPI definition. So here we now see our product API definition file within SwaggerHub. And what we can do is add another object here. So we're going to add the tags object. And then within the tags object, we're going to build out a new tag, and we'll give this tag the name product, and then we can provide a description for this tag. We can say this is a product related operation, and now we can navigate into our different operations within the API definition and tag them. So here we add the tags object underneath our get operation, and then we can go ahead and specify that this is related to the product tag. So we'll just copy that YAML and add it within each of our operations. So there we'll apply it to the post, and then finally we can add it within our get for the product path. Okay, and then once our API definition validates, you can see within our documentation, we now get the product tag, and all of the endpoints with that tag are grouped together in the API docs. So this is an excellent way that we can organize our operations within our API documentation, making them easier to consume for our API clients. APIs can expose sensitive data and operations that we want to protect from unauthorized access. OAS provides us with a security scheme to define how an API is secured so that we can protect those sensitive resources. Within SwaggerHub, we can use a template to easily define a security scheme. So let's create a new API definition, and within the dialog box, we want to make sure that it's version 3.0 of the OAS spec that we're using. And then within the templates, you'll notice that we have several templates that are dedicated to providing security schemes for several OAuth flows. We're going to go ahead and pick the password flow, and at this point we're going to name our API the security template, and we can go ahead and create it. Once the API is created, we're navigated into the editor, and if we scroll down to the bottom of this API definition, you can find the security scheme that was created within the template. The security scheme specifies that we're using OAuth, and then it further specifies that we're using the password flow. Here you can see we're able to specify the token endpoint that an API consumer can receive an access token from once providing the appropriate parameters defined by the OAuth protocol. And then within this, we also define our scopes, and we have two simple scopes, write and read. So let's grab this portion of the API definition, and we can copy it to our clipboard. And now we're going to navigate back to MyHub and into the H plus Sports API definition. At the bottom of our API definition, we find our components object, and that's where we can place our security scheme to be reused throughout our API definition. At this point, securing one of our operations on the API is extremely simple. So let's scroll up, and we're going to secure this post operation on the product path because we don't want anybody to be able to create a product within the H plus Sports catalog. So to do that, we simply use the security object underneath our operation, and then we're able to specify in an array the password property, and inside of the password property, we simply place one of the scopes that were found within our security scheme. So here I'm specifying the write scope is used to protect that post operation. At this point, we can save our API definition, and now if we scroll down, you'll notice this little lock shows up within our interactive documentation, and that's denoting that this operation on the API is secure. So if you've ever worked with an API and had to authenticate in order to access a secure API resource, you know how valuable it is to have this sort of information as a consumer of an API. So this is going to increase your API adoption. Now, one of the other things I'd like to cover while we're here, we no longer need the security template. So if we navigate into the security template API, we can click on the name, and here we get some options. So you have the ability to fork the API, you can transfer ownership to another organization or another user of SwaggerHub, and then here you see the ability to delete an API. You'll need to confirm via this dialog that you no longer need the API. So let's just go ahead and do that. and that's going to return us back to MyHub. And then the other thing we're going to do is change this name. It's not too friendly for this API. It's our catalog. So what we'd like to do is change this over to the H plus Sports Catalog API, and then we can actually change the API name by renaming it within SwaggerHub. So let's just call this Catalog, and we can rename the API, and it's going to tell us we have unsaved changes. Let's save those. And now, with those changes in place, you'll see that we have the Catalog API within the H plus Sports organization. A domain in SwaggerHub provides the capability to reuse OAS definition objects such as schema definitions, path items, parameters, and responses across multiple API definitions. The ability to reuse objects across API definitions helps maintain consistency amongst an organization's catalog of API definition files. It also allows them to deliver API definitions more quickly because of the reusability we achieve. So let's go ahead and create a domain for the H plus Sports organization within SwaggerHub. To do this, we click on the plus button on the left-hand sidebar and then go to Create New Domain. Now, within the Add New Domain dialog, it is extremely important that we select OAS 3.0. From there, we can specify the name of our domain. I'm just going to say H plus for short. After that, we can set our version number, which I'm going to set to version 1.0. With this information in place, we can click on Create Domain, and our new domain will be created and we're navigated to the editor. You'll notice within the editor, we already received this template for creating a domain. Now, it's set up for this Acme Components domain. Let's tailor that for our H plus Sports domain, and we'll adjust the description. These are components for H plus Sport. And then if we look further down within this domain definition, you'll see the important sections. So here we define schemas, parameters, responses, request bodies, all of the reusable objects that we would like to be able to use across API definitions. Now, for our purposes, we are only interested in the schemas section. So I'm actually going to remove everything else and then go ahead and save our domain. And now within MyHub, I'm going to navigate into our customer API because we'd like to be able to reuse our customer schema across multiple API definitions within the organization. So I'll just go ahead and copy that, and then we can navigate back to MyHub and into our H plus domain. Now, if you do not see the H plus domain, do not be alarmed. There may be a filter being applied on your list. If there is, you'll see an option to clear it right about here within the search bar. For now, I'm just going to head back into that domain, and then we're going to replace the error model with our customer schema. So there we see our customer schema is now in place. So let's save our domain once again, and it's ready for use. So let's publish it. At this point, we have version 1.0 of the domain published, and we can now reference the customer schema defined within our domain inside of our customer API. You'll notice that our customer API is currently read-only, so that means we need to add a new version. This is going to be version 3.0 of the API definition, and now we can edit it. Since we have defined the customer object within our domain, we can go ahead and remove the entire components object, and now in the 200 response, where we reference the customer using the ref property, we can select the customer within our domain. So just hit Control Space, and you're going to get some auto-completion where you can select the available schemas within our domain. And there you can see that we point to the H+ domain and the customer object found within it. If we scroll over and look at our API operation, you'll notice that we still have our customer schema defined as a response for this API operation. That definition is now just coming from our domain instead of locally within our API definition. If you have a large catalog of APIs within your organization, I strongly encourage you to take advantage of SwaggerHub's domain feature. Domains are an extremely powerful concept within SwaggerHub. So we're going to walk through another demonstration that gives us more experience building out schemas within domains and also nesting some of our schema objects. So let's navigate into the H+ domain, and you'll notice that we've published our first version. So in order to edit the domain, we'll need to create version 2. So we'll go ahead and add this version. And now we can make some changes inside of our domain. So we're going to work to build out an ordering capability within our catalog API. That capability is going to refer to an order schema that we're going to build within our domain. So we'll define a new schema named order, and it's going to be of type object, and within that schema object, we're going to have different properties, including an ID, which will be of type integer, and we can give an example of this ID property. And we're also going to include a product ID so that we know what the customer's ordering, which will also be of type integer, and we can give an example here. And then we're also going to grab the quantity. So we want to know how many of these items were ordered by the customer. So that will be an integer as well. And then we're going to specify an order date. So this will tell us when the order was placed. And this is going to be of type string, but we're going to do something different here where we specify a format property that says this string is using the date-time format. Now, within the OAS specification, there are several string formats described. So you can use things like a UUID. There's others regarding date and time. So anytime you have a string that has a well-known format, it's worth a glance at the spec to see if that format is defined so that you can leverage it within your API definition. Now we're going to provide an example of our date time, and that means we need to specify the year, followed by the month, and then the day. After we have our date, then we place a T in our string, and then we can specify the hours, minutes, and seconds that the order was placed, and the final thing we need to add is the time differential from UTC. Okay. So there we have our order date property, and we're just going to add one additional property, the customer property. And the customer property is actually going to refer to an existing schema within our domain, and that's the customer schema we see on line 36. So in order to reference that, we use the hash sign, and then we just specify the path to that schema object within our file. So it will be within the components section of the file, and then nested within that is schemas, and then finally we have the customer schema itself. If we inspect our API documentation, you can see that the order schema has a nested customer schema defined within it. So let's go ahead and save our domain, and then we're going to publish the second version of our domain. Okay, so now that that's in place, we can navigate into the Catalog API. The Catalog API is where we're going to place the order path so that we can define a post operation to this path. Now, because this operation is going to allow an order to be placed, we need to put some security in place. To do that, we use the security property, and within the security property, we're able to supply an array where we can point to security schemes that we defined. So we know we've defined our OAuth password flow within our security schema, and we're going to protect this endpoint with the right scope. So anybody invoking this needs to have the right scope. Okay, now that security's in place, the next thing that we specify is the request body. The request body details the data that an API consumer needs to send when invoking this operation. So inside of the request body, we specify the content property, followed by our media type. In this case, we're going to be using JSON. And then we can go ahead and specify our schema using the ref property. And here we can point to our order that we defined on the domain. And you'll see with auto-completion, the SwaggerHub editor is able to supply that path, taking that burden away from us. Okay, now for any operation, we also have to specify the responses for that operation. So here we'll specify what a 200 response looks like. So this is going to be a successful response from the API. And now we have that in place. If we would like, we can also return some data from this operation. So you just put the content property in place, followed by a media type, and then within that, the schema. And finally, we can specify a ref. So let's say that we just want to return the order object back to the API consumer to indicate that we have in fact processed their order. Okay, so now we can see the new order operation on our API, and we can see that we get the order schema that's provided via the response, and also the order schema being used as the request body provided by the API consumer. Excellent. So let's go ahead and we will save this catalog API because that concludes our work with domains and nested schemas within our domain definitions. Within SwaggerHub, we can encourage the adoption of best practices for an organization's API definitions by establishing standards at the organization level. To do this, we just click on the organization name on the left-hand sidebar, and then we navigate up to this gear to enter the organization settings. Within this section, we are able to specify some details about the organization. We can also specify the members of the organization, and then what we're interested in is the Standardizations tab. So on this tab, we are able to select different standards that will apply to the H+ Sports organization's API definitions. You'll notice that we're able to mandate that certain properties within the info object be required for our API definitions. We're also able to require that certain information be provided for our operations, and then we can set standards for models as well. For our purposes, we're just going to apply one standard, and that's that operations must have one and only one tag. So let's go ahead and check the checkbox next to the standard and then hit Save. At this point, we can navigate back to MyHub, and you can see that our catalog API definition does not conform to this standard. Let's go ahead and correct this. It appears that the order path and its post operation are in violation of the standard. So let's fix that. The first thing we'll do is create a new tag that is named order, and we'll provide a description. We'll say this is an order-related operation, and then we can navigate within the post object and add a tags property. Inside of the tags property, we can specify an array of tags that apply to this operation. In this case, we want to specify our order tag. So with that in place, we can go ahead and save the API definition. You'll notice that the error disappears because we now conform to the organization's standards. And if we return to the MyHub view, we no longer have the warning regarding our API's non-compliance. So using the standards within SwaggerHub, you're able to enforce quality within your organization's catalog of APIs. As an API development platform, Swagger supports the ability to mock APIs while they are under development. This feature enables parallel development of API implementations and consuming applications to occur because both teams are working based off the API's contract. Let's take a look at this feature in action. If we navigate into our customer API, we can preview the Swagger UI docs by clicking on the View Documentation in the upper right-hand section of the screen. This will allow us to see the customer operation exposed within this API definition. You'll notice that we have the option to try it now. If we select the Try It Now option, we're going to be given the Execute button, where we can go ahead and execute a request against this API operation. You'll notice that we are able to see the response provided back from the API, and that's because SwaggerHub is providing this virtual server that's mocking the API. So if we grab this URL and we copy it and put it into the browser, you'll notice that we get some JSON returned. So if you're an API consumer of this API, you can go ahead and program against this contract while the API implementation is being developed. Now, if we navigate back to MyHub and look at our catalog API, we can go into the Swagger UI docs, and if we take a look at one of these operations on the API, you'll notice our Try It Now button is missing. And that's because we imported this API definition, and during the import, SwaggerHub doesn't stand up the auto-mocking feature. So let's see how we can put it in place in this situation. So the first thing that we'll do is click on the name of the API, and then we can click on Integrations. Using this dropdown, we can select from several integrations that SwaggerHub provides. In our case, we need the API auto-mocking integration. So we'll go ahead and select it, and then click on Add. At this point, we can now provide a name for the integration. So let's just call it auto-mocking. And then we can create the integration, and it's now in place. And we can take a look at its configuration because there's an important section here that we need. You'll notice that it says it automatically creates a mock for this API, and then it specifies the format of the URL for the mock. So let's go ahead and copy that because we need to add a server definition into our API. So at the top of the catalog API, we're going to go ahead and specify the servers property, and then inside of the servers property, we can specify a description. So let's say this is the SwaggerHub API auto-mocking server, and then we go ahead and provide a URL. And here is where we need to complete some of these template parameters within the URL. Now, you'll notice it requires the owner, the API, and the version. Conveniently, those are found within the URL of the editor. So let's just go ahead and copy that. And then we can put this in place by pasting that into our API definition. And now if we view our documentation, we can expand one of our API operations. Oops, it's still missing. So let's go ahead and save this in order for it to take place. Okay, with that saved, now we can preview the docs. And if we expand one of the API operations, we now see that the try it out feature is available, and we can go ahead and execute a request against a mocked version of our API implementation. And there we see the response. So we can go ahead and grab that URL, and we'll test that out within the browser as well, just to make sure everything's working. And once again, if we were an API consumer, we could perform development against this virtual server, which provides mocking of our API. SwaggerHub delivers several collaboration features aimed at making it easier for teams and collaborators to work together to build API definitions. We can add a collaborator to an organization's API catalog by clicking on the organization in the sidebar and then navigating to the gear in the upper right-hand corner to access the organizational settings. Within the organizational settings section, we see the Members tab, and here we can invite members to collaborate on our API definitions. In order to invite a collaborator, all we need to know is their SwaggerHub ID or their email. In this case, we're going to invite the Swagger Course 2 user to collaborate on the API definitions for the H+ Sports organization. So we'll go ahead and select that SwaggerHub member and invite them. And you'll notice here in a second that we will have this individual added to the members of our organization. Let's go ahead and make this individual an owner. So we're going to give them some pretty high-level permissions. Now, you'll notice that it's indicating an invitation has been sent to this user. That invitation is sent via email, and this individual will need to accept our invitation once they receive the email inviting them. I'm going to refresh the page so that we can see the member's status will update once they've accepted the invitation. There we see that the individual with the username SwaggerCourse2 has joined our H+ Sports organization. Now at this point, I'm going to go to a separate browser, and here I'm logged in as the SwaggerCourse2 collaborator. And that individual is actually an owner of our API definitions. And you'll see that when I refresh my hub for this user, we now have access to APIs and domains within the H+ Sports catalog. So if I navigate into the catalog API, here this individual is able to make updates to the API in order to collaborate on their development within the organization. Now, another neat feature in SwaggerHub is we get the ability to make comments on an API definition. So I just click this little plus button to the left of a line number, and then I can describe some change I would like to see made to the API. And this capability is able to facilitate collaboration amongst the team members of the organization. So in this lesson, we saw how to add a collaborator at the organization level, and this allows us to team up to build API definitions for an organization. Within SwaggerHub, we can also manage access to API definitions at a more granular level. So I'm going to navigate into the organizational settings for H+ Sports, and we're going to remove the SwaggerCourse2 user from the organization. And at this point, I'm going to go back into my hub, and I'm going to invite this individual only to collaborate on the catalog API. To do this, we just click on the Share and Collaborate button in the upper right-hand corner, and within this dialog, we are able to invite individuals to collaborate on a specific API as opposed to our organization's entire catalog. So here we can just specify the username Swagger Course 2. And once we find our user and identify them, we can then confirm that we would like this individual to collaborate on this API. And at this point, they would now have access to the catalog API definition. We can navigate over to the Swagger Course 2 user. Once we refresh their MyHub, you'll notice that access to the other APIs within the H+ Sports catalog are no longer available. They only have access to the catalog API definition. So using this more granular approach, we can invite individuals to collaborate on a single API as opposed to our organization's catalog. It's time for the last challenge. In this challenge, you will get some practice working in SwaggerHub and defining secure API operations. To complete the challenge, you'll need to import the blog API definition into SwaggerHub and publish it. Next, create a new version of the API definition that secures the post operation that allows new articles to be created. Since this capability allows articles to be created and published, it should be protected. When defining the security, use an API key-based security scheme. Once the new version has the security scheme applied, publish the new definition. This challenge should take you about 10 minutes to complete. In the next video, you will see my solution. Good luck! Let's take a look at one way to complete the last challenge. To get started, I'm going to import the blog API definition into SwaggerHub. To do that, I just click on Create New, and then I can go to Import and Document API. Within the Import API dialog, we can click on Browse, and from here we can navigate into the exercise files to find our API definition. You'll notice the 03_14_begin file within the exercise files. If we click on that, we can then leave all of the defaults in place on the dialog and click on Upload File. The next dialog is going to ask us to provide a name for this API. I'm going to name this API H-plus-blog-API. With that name in place, I'll go ahead and click on the Import OpenAPI definition, and that's going to upload our YAML file into SwaggerHub. Once the API definition file has been imported, I'm just going to go ahead and resize a few of these windows so that I can see the YAML better. Okay, now let's go ahead and publish the first version of this API definition. You'll notice this drop-down at the top that has the version of our API definition. If we click on that, there is an option to publish the API. Let's click on that option, and it's going to ask us if we would like this API to be published privately or publicly. I'm just going to leave it as private, and then click on Publish Version. Okay, now that we have published the API, let's go ahead and make some changes to it by adding a security scheme. In order to make any changes, we'll need to create a new version since this API definition has been published. To do that, once again, we click on the drop-down associated with the current version, and then we click on Add New Version. Here, I'm just going to make the new version 1.1.0. Once I have that version in place, I can click on Create New Version, and now we're able to make changes to our API definition. The changes we're going to make are going to secure the post operation on the article endpoint. In order to do that, we'll need to build a new security scheme into the API definition. We do that within the components section of the API definition file. So underneath the security schemes field that we've added, we just specify the name of our new security scheme, and then nested within that, we can specify its type, which in this case is going to be API key, and you'll want to make sure that you've capitalized it as I've specified. Then we'll provide a name of API-key, and then finally, we're going to specify the in field, and this is going to say where we expect to find the API key in this security scheme. Okay, so the security scheme is defined. Now, let's go ahead and add it to our post operation. So underneath the post operation, I'm just going to add the security field, and here I can go ahead and reference our new API key security scheme. Having made these changes, let's go ahead and save our API definition. And once it's saved, we can then publish the new version of the API by clicking on the Publish button, and then within the dialog, clicking Publish Version. Okay, if we'd like to take a look at these changes, we can click on the View Documentation button in the upper right-hand corner. So you'll notice that our post operation on the article endpoint is now secure, and that's indicated by this lock on the right-hand side. If we click on it, it will give us some information about the security scheme and what is expected in order to use this endpoint on the API. Okay, with the API definition secured, we've completed our work for this challenge. Great work! In the last chapter of the course, we will build a small catalog app for the H+ Sports Company. The app will be architected using an API-centric solution that takes advantage of our API definition files to generate many of the components in the system. The project will demonstrate a design-first approach to API development and introduce a few cloud-based API technologies. I invite you to follow along, but you are also welcome to simply observe how the project is created. However you choose to handle the final chapter, I promise you will gain a better understanding of how API definition files built with Swagger and OAS can deliver API-based systems more quickly and efficiently. At the core of our project is the H+ Sports Catalog API definition file that we created on SwaggerHub. We'll use the API definition file to generate several components in the system. We'll build out a virtual server that can mock API calls, and an Angular client SDK for calling that API. Also, we'll create a Spring-based server stub that provides the beginnings of an API implementation. We'll then integrate the client SDK into a small Angular application so that it can retrieve mock product data from the virtual server running on SwaggerHub. The Angular app will use the product data to build out a simple interface containing the H+ Sports product catalog. It's important to mention that we have not even created the API implementation at this point. Thanks to the mocking capabilities of SwaggerHub's virtual server, we can use design-driven development to build API consumers separate from the API implementation. The server stub generated by SwaggerHub will then be augmented to include API logic that provides product data for the key API operations. After we package the API implementation into an executable jar, we'll upload the artifact and host it on a Linux server running in Azure. If you use another hosting environment, it can take the place of Azure in the project. Finally, we'll replace the SwaggerHub virtual server with an API gateway named Apigee that proxies traffic to our API implementation on Azure. API gateways like Apigee can manage an organization's API catalog in a single platform, solving common API concerns like throttling or security in a central location. This project will help you better understand how Swagger and OAS can deliver API-centric solutions while giving you a peek at some cloud-based platforms that support API development. To kick off our course project, we're going to generate a server stub and client SDK for our HSports catalog API. To do that, we just navigate to the API definition within SwaggerHub, and then using the export option, we're able to export a client SDK as well as a server stub in various languages and frameworks. So let's first build out our server stub, and we're going to be using the Spring framework. So we just click on Spring, and then SwaggerHub's going to prompt us for where to save the generated code. So we're going to put this code within the course workspace folder of our desktop, and let's go ahead and name this downloaded artifact the HSports catalog-server file, and we'll go ahead and download that. And now we can build out our client SDK. For our client SDK, we're going to be using TypeScript and Angular. So go ahead and select that option. We're going to be prompted for another download. This time, we're going to go ahead and name this downloaded artifact hsports-catalog-client. So with the code generated for our server stub and our client SDK, we're able to continue with our project. You'll notice how much time we saved by not having to code the actual server stub or client SDK. This increases our time to delivery thanks to SwaggerHub's CodeGen feature. In this lesson, we'll build a small Angular application that uses the client SDK that we generated from SwaggerHub. If you would like to follow along, you must have Node.js, Angular, and Visual Studio Code installed on your workstation. To get started, I'm going to navigate to the course workspace where I've positioned several zip files. The first zip file is the HSports client app zip file. It contains a small Angular application that's provided within the exercise files for this lesson. Let's go ahead and extract this Angular app into the root of our course workspace. Once that's extracted, we're going to extract the HSports catalog client zip file. If you'll remember, this is the client SDK that we generated from SwaggerHub in the last lesson. Just go ahead and extract this right into our course workspace directory, and then what we need to do is navigate into the HSports catalog client directory. This directory contains all of the code for our client SDK. We're going to copy that code, and then we're going to navigate over to the HSports client app. This is the Angular application, and within the source app rest directory, we're going to paste the client SDK. Okay, at this point, we can navigate to Visual Studio Code, and we're going to open that folder. So click on Open Folder, navigate to the course workspace directory, and then open the HSports client app directory. At this point, the HSports client app is loaded within Visual Studio Code, and we can go ahead and open a new terminal. Within the terminal, I'm just going to clear it in order to save some space. Now, we can use the Node Package Manager to install the packages within our Angular application. To do this, we issue the npm install command. Okay, it looks like all of our npm packages have loaded. Let's clear the console, and now we can serve our application. It looks like the app's up and running, so let's navigate to a browser where we can access the application on our localhost at port 4200. Here we see the basic Angular app in action. it was able to send an API call back to the virtual server running on SwaggerHub, and here we see the results. The one thing you'll notice, we're unable to load an image from the virtual server. That's because it doesn't have the image files for the API. We'll get to that later. If we take a look at the code for the app, we can see how our client SDK called back to the API. So the first thing we'll take a look at is the appcomponent.ts file. This is the TypeScript file that's associated with our app component. You'll notice that it uses a product service. This product service is provided from the client SDK that we generated with SwaggerHub. We can navigate into the REST directory and then into the API directory in order to see the product service. I'm going to go ahead and hide our sidebar in order to get a better view of this code. Okay, if we scroll down into this file, you'll notice that the product service has a URL to the SwaggerHub virtual server where it's making the API calls. All of the code in order to perform the calls to our API is contained within this service. So here we see our operations and the corresponding TypeScript that we need to make the calls from the client SDK. All of this code was generated for us by SwaggerHub. Swagger can generate the server-side stub for our API. However, we still need to code some of the API implementation. In this lesson, we will build out the remainder of the API implementation using Java and Spring. If you want to follow along, you must have a Java 8 JDK installed and Eclipse installed on your workstation. To get started, I'm going to navigate to our course workspace where I have the hsports catalog server zip file. You may remember this from when we generated our server-side stub for the hsports catalog API. We're going to go ahead and copy that zip file, and then I'm going to paste it within my Eclipse workspace. I've placed my Eclipse workspace on my desktop. So inside the workspace, we just paste the zip file, and then we go ahead and extract that zip file into the workspace. Once it's extracted, we can navigate back to Eclipse. And now we're going to import the project which was created using Maven. So just type existing Maven project. And here you see the option to import a Maven project within Eclipse. So go ahead and hit Next, and then click on the Browse button, and it's going to open to our Eclipse workspace, and then we can just select the hsports catalog server directory, which contains the server stub generated by SwaggerHub, and you'll notice it pulls in our pom.xml file because this is a Maven project. Just go ahead and hit Finish, and Eclipse will start to import the server stub into the workspace. Okay, so we see it's imported, and from here, we can see the code generated by SwaggerHub. Now, this isn't the full API implementation. We still need to build out the code that provides our data and capabilities. So what I've done is within the course workspace, I've placed a product service.java file, which you can find in the exercise files for the lesson. Just go ahead and copy that, and then navigate over to your Eclipse workspace and into the hsports catalog server directory. Inside that directory, we're going to go to source, main, java, io, swagger, and then API. And here we will paste the product service class alongside all the other API code. Now if we return to Eclipse, we can go ahead and refresh the Project Explorer to see the product service. Once we open the product service, we can take a look at the code within it. All we've done is provided the product data within within an array of JSON product objects, and we're using that array in order to serve up the various products. So all the data for our products is contained within this class. And then we just have two methods, the getProducts method that provides the entire array of products, and the getProduct method that accepts an integer, which is a product ID, and we can use this to get a specific product within the array. So this is how we're kind of mocking out the catalog data. If we return back to the Project Explorer, we will need to provide some implementation within the Product API Controller class. So what we'll do is we will auto-wire the product service within this class. So using Spring's auto-wiring capabilities, we can inject the product service, and then we can leverage it within the implementation of this controller. So we'll need to modify these three controller methods that correspond with the API operations that we expose. You'll notice that at the moment, they're returning a not implemented HTTP status. Let's change all of these over to return a 200 OK. From there, we need to make adjustments to two of the controller methods. The first is the product get method, which returns the entire catalog of products. We need to specify a list of products as the first argument to our response entity constructor. So here I'm going to use the product service to get a list of products that get returned from the API implementation. And then within the product ID get method, here we're returning a specific product for the operation that leveraged the template parameter. So here we just use the product service to get a product by its product ID. And at this point, we've built out our API implementation. All that's left is a little bit of configuration. So to finish off the configuration of the API, we're going to navigate to the source main resources directory and open the application.properties file. We need to switch the port from -1 over to 8080, where we're going to run our API implementation. Just go ahead and save the application.properties file. And while we're here, I want you to note this context path. So this is the base path that's going to be exposed after our domain when we make an API call. You'll see what I'm talking about in a little bit. For now, just copy this context path. Now we're going to start up the API implementation. To do that, we just right-click on the Swagger to Spring Boot class within the source main Java folder. Once we right-click on that, we go to Run As and then Java Application. This is going to start our API implementation. We can watch it in the console. And here you see that it's started and it's running on port 8080. So at this point, we can go ahead and open up a browser, navigate to localhost on port 8080, and then we need to specify that context path we talked about earlier. And then we add /product to invoke the product operation on our API. There we see all of the data for the product list, and that's our entire product catalog exposed by the HSports Catalog API. And then we can leverage our operation that accepted the template parameter by specifying a product ID within our URL. And here we see we can access a specific product through the API operation. So there you have it. We just build out our API implementation using the server stub we generated from SwaggerHub. Once we've built out our API implementation, we'll need to package the API for deployment to a server. Luckily, we're using Maven, which makes it extremely easy to package our software. Just right-click on your project and then go to Run As, then Maven Build. Within the dialog box, we need to specify two Maven goals. So specify the clean goal and then the package goal. We'll also need to select the skip tests option, and then we need to ensure that we're running our Maven build using a JDK. To do this, click on the JRE tab and then click on alternate JRE. You'll notice we're set up to run with a JRE, so we can go to this Installed JREs button, and here we can add a JDK. So click on Standard VM and then hit Next, and now we'll use the Directory button to search for our JDK. My JDK is installed within C, Program Files, Java, JDK 1.8.0_211. All I need to do is select this folder and Eclipse will load the JDK. Then we need to click on the JDK in order to use it within our run configuration, and then make sure we select it as the alternate JRE. Okay, at this point we can apply those changes and run our Maven build, and Maven will begin to package our software. There we see that our build has succeeded, and if we navigate to our Eclipse workspace and into our project, you'll see the target directory where we now have a jar file that contains our packaged API. Once we have built and packaged our API implementation, we'll need a place to host it. In this lesson, we'll see how easy that is with a cloud service like Azure. If you're not familiar with Azure, it's Microsoft's cloud platform that allows us to quickly provision a variety of virtual machines. A trial account is free and easy to set up. All you need to do is click on the free account link on the Azure homepage. It's okay if you do not use Azure, but this lesson will require that you have a server with Java installed and publicly exposed ports. Since I have an account, all I need to do is click on the portal link to enter the Azure portal homepage. Here we see the options we have, and in order to provision a new virtual machine, we just click on the virtual machine icon, and from there we can go ahead and add the virtual machine, and this will take us into a form where we can specify the details of our virtual machine that we'd like to provision. The first thing we'll need to do is create a resource group by clicking on the Create New link. I'm going to name this resource group hsports-resources, and then go ahead and click OK. We'll then scroll down where we can provide a name for our virtual machine. Let's name this machine the hsports-api-server. Next, we'll select the OS image that we would like installed on the machine. In this case, we're going to use an Ubuntu image, version 16.04, so we'll have a Linux distro. Scrolling down, you'll see that we can specify the authentication type for our administrator account. I'm going to go ahead and set this to password, and then for the username of the admin account, I'm going to specify the hsportsadmin. And then from here, we'll need to enter the password for this new admin account. With the admin password in place, the next thing we'll do is open up the ports available on the server that are exposed externally. So click on the Allow Selected Ports radio button, and then we're going to specify that we'd like to allow HTTP, HTTPS, and SSH. At this point, we've provided enough details for Azure to create our new Linux VM, so let's just click on Review and Create. It appears that our virtual machine has passed validation, so we just need to click Create one more time. You'll now see that Azure has begun to deploy our new Linux VM. And it's that easy with Azure. In just a few minutes, we can build out a Linux VM that we can use to host our API implementation. Once we've provisioned a new VM, we'll need to stand up our API implementation. To do that, we'll need to run the jar file on the server using Java and set up DNS resolution. So the first thing we'll do is FTP the jar file over to our new VM. So if we navigate into the VM that we provisioned, you can find the IP address for the server. Go ahead and copy that and use that IP to log into the server with your favorite FTP tool. I'm using WinSCP, which is a free FTP tool that you can download. You'll notice on the left-hand side, I am logged in on the local workstation and in the desktop directory. And here I'm going to navigate into the Eclipse workspace, then our H Sports Catalog server project, and then inside of the target directory, we're going to find our API implementation packaged in a jar file. We're going to transfer that jar file over to the server, and then we can start navigating back to Azure. Within Azure, we can scroll down on the sidebar of the VM console, and you'll see that we can open up a shell using the serial console. So I'm going to up the font size here to make it a little bit easier for you to see. Okay, it's going to prompt us to log in. We'll use the admin credentials. Okay, so there we're logged into the shell of the server. We can go ahead and clear the console, and then what I'm going to do is sudo to the root user. And at this point, we're going to make a new directory named API in the root of the server, and then we're going to navigate into that directory. And at this point, we can copy the jar file from the temp directory into our API directory. Now we need to make sure that Java's installed on the server. So to do that, you can use apt, just apt install default-jre. And this will make sure we have Java. Looks like it's already installed on this machine. So I'll go ahead and clear. And then what we're going to do is use the nohup command, and we can use that to execute Java's jar command. And then we can provide some arguments to the JVM when it starts. So we do that with a -d flag. And we're just going to say that we want the server to run on port 80 using the server.port argument. Okay, so we set that to 80. And then we point to our jar file that we'd like to run, and then just add the ampersand after that. Go ahead and hit enter. That's going to fire up our API implementation. Now, in order to see this in action, we can go to the Overview tab, copy the IP address, and then within a browser, you can see that I'm sitting on the local instance of our API implementation. And you can see that because we're on localhost port 8080. So if we just replace localhost port 8080 with the IP of our new server, you'll see that we can actually hit our API endpoints. So that's great, but we don't really want to have to use the IP address. So let's set up DNS using Azure. So to do that, you can access the DNS name configuration on the overview for the VM. You'll see this configure hyperlink, click on it, and then you just need to provide a DNS label. So let's set up our DNS as H+, and then you'll notice we get the region added for Azure here. So with that in place, we'll just go ahead and hit save. And that's going to start building out our DNS resolution for the server. We can navigate back, and in a second here, we will see that our DNS should take place. There it is. So let's copy that domain name, go back to the browser, and we're going to replace the server's IP with the domain name. And there you go. We have DNS set up for our API implementation running on Azure. Now that we have a production instance of our API running, it's important that we go back to our API definition and update the servers section to include this new server. So within SwaggerHub, we're going to navigate to our catalog API that we are hosting, and within the API definition, we're going to add a new entry within the servers array. So we'll add a description. We'll say this is the production instance. And then we need to provide a URL to our production instance of the API. Now, I still have a tab open that is directed to our production instance of the API. So I'm just going to go ahead and copy everything before product. And then we can head back to the API definition and paste this in. At this point, we'll save the API definition, and then if we view the documentation, you'll notice a few things. First, we have 2 instances of our API within the servers dropdown. And now if we were to view one of our operations, let's say this product operation, we're able to try it now, and this time we can execute against our production instance. So here we see the results from the production instance of the API. And let's just grab this ID from product 438. We'll copy it. And then we're going to navigate to another operation that accepts a template parameter, which is a product ID. And we'll try this out as well. So let's adjust our security header. And then we can put the product ID in, and now we can execute this request, and you'll see that we get the product returned from the API. So with that change in place, let's go ahead and publish our catalog API. So click on the version, and then click on Publish, and we're going to make it public. And then finally, we just click on the Publish Version button. And at this point, our API is now available for consumption by external API consumers. If we would like to share the link to our API, we can find that link within the Share and Collaborate button. And here in that dialog, you'll see the link we can share with others that we would like to collaborate on this API. So there we have our API definition file updated with the latest production instance. Our docs are in sync with our implementation, and we're ready to move on to the next step. In this lesson, we'll use Google Apigee to introduce an API gateway in front of our API implementation. When organizations develop a large catalog of APIs, an API management platform like Google Apigee can help centralize management of common API functions such as security, throttling, monetization, monitoring, and error handling. For those of you following along, Apigee provides a free developer account that you must register for before beginning this section of the course. All you need to do is click on the free trial button in the upper right-hand corner on the Apigee homepage. I have an account, so I'm going to go ahead and sign in. When we log into Apigee, we're presented with the homepage. The first thing that we'll want to do is create a new specification within Apigee. You'll notice it's referencing an OpenAPI specification. Once we click on that option, we're going to add the spec by clicking on this blue button in the upper right-hand corner. Now, you'll notice we have 3 options. We can create a new spec, we can import a spec from a URL, or we can import a file. We're going to use the import URL option, And you'll remember that our API definitions are sitting in SwaggerHub, and that's where we're going to import them from. So first, let's specify the name of the import. We'll call it the hsports-catalog import. And this next part's a little bit wild, so bear with me, but it's the recommended approach. So when we need to reference an API definition in SwaggerHub by the URL, we can follow this guide provided by SwaggerHub. If we scroll down in this guide, it will tell us how to download an API definition via a URL. And basically what it instructs us to do is take the URL within SwaggerHub and replace the portion of the domain that says app with API. And then, if we would like, we can add swagger.yaml at the end of the URL to get the API definition in YAML format. So let's navigate to SwaggerHub, and we're going to enter the catalog API, and we'll follow these instructions. So grab the URL, and then let's put it in a new tab. We'll change app to API, and then we're going to suffix this URL with swagger.yaml. Just go ahead and hit enter, and if you're prompted to download a file, you know you've done it right. So copy this URL, head back to Apigee, and then paste it within the import URL text box and click the import button. At this point, you'll notice we get a new specification within Apigee. We can click on it, and when we open it, you'll notice it opens in Swagger. So within Apigee, they're using Swagger to modify OAS API definitions. Now, we don't need to make any modifications, except we want to copy the URL for our production implementation. We're going to need that in a second. So just go ahead and copy the URL to Azure for our API implementation, and then hit cancel. The next thing we're going to do is set up a proxy to our API implementation running on Azure. So over in the left-hand sidebar, click on API Proxies. This is simply going to pass traffic from Apigee back to our API implementation running on Azure. So to create the new proxy, just click on the blue proxy button, and then we're presented with the list of different proxy types that Apigee provides. In our case, we just want a reverse proxy. We want Apigee to pass the traffic back to Azure. So leave that option selected, and then click on Next. Next, we need to provide a proxy name. So let's name this proxy hsports-catalog. The next field we'll need to complete is the URL of the existing API at Azure, and that's where we're going to paste the configuration we copied from our API definition. So now that we've configured the API proxy, go ahead and hit Next, and we need to specify some security. So first, we want it to be a pass-through, and then we also want to check this option to add course headers. With those options checked, we can go ahead and keep the production and test environments. So just hit Next, and then we can check the prod environment when we're specifying our builds. Go ahead and hit Build and Deploy at this point, and Apigee will start building out our API proxies. You'll notice that the proxy's now ready, so we can go back to the API proxy section, and if we inspect the hsports-catalog proxy, you'll see that we are presented with the URLs for our API proxies. So let's just copy this link, and then we'll go to a browser and paste it in order to access the API running on Azure. So I can hit the product endpoint on our API implementation, and there we see a response that's running through the Apigee proxy to our API implementation on Azure. Now that Apogee is proxying the traffic to our API implementation, we're able to take advantage of some of its features that it centralizes for the API. So in this lesson, we're just going to take a quick look at the monitoring feature within Apogee. So we'll first navigate into our HSports catalog proxy. And inside of the proxy definition, we see our two environments. Let's copy the URL for our prod environment, and then we can paste it into the browser and hit our product endpoint. At this point, I'm going to remove the tab from the browser, and we can navigate within Apogee to the API proxy performance option via the sidebar. So just click this third icon down and then API proxy performance. This is going to give us an understanding of all the traffic navigating to our API through the proxy established by Apogee. So when I send a bunch of HTTP traffic to our API, Apogee is going to capture that traffic and register it within this display. So here we see the traffic that has been sent to our API over the past hour. So this is a way that we can monitor the response times and the traffic to our APIs. One thing you should note, there is a slight delay in the monitoring, so it won't show up real time, but it does give you a good understanding of API usage as well as response time. There's one final piece of our course project that we need to put in place. We need to set up our Angular application to use the Apogee proxy URL so that the application accesses the production instance of our API. So within Apogee, navigate to the proxies, and we'll grab the HSports catalog proxy. And inside of the configuration, we can grab the production URL, so just copy this address. And now we're going to head over to Visual Studio Code, where I have the HSports client application loaded. So within this Angular application, we're going to expand the source directory, and then the app directory, followed by REST, and then API. Inside of this directory, you'll find the product.service.ts class. Go ahead and open this class, and then I'm going to hide the sidebar so we can get a better view. If we take a look at the class, you'll notice within this TypeScript file, we are still pointing to the mock API server running on SwaggerHub. Now, this worked out great before we had an API implementation in production. It allowed us to develop before the API was ready using the contract-first approach. Now that we have a production API, we're going to go ahead and switch over to point at the production implementation. So just paste the URL that we copied from Apogee that points to our API proxy and save the file. Now we can go ahead and use the ngserve command to run our Angular application. This will cause Angular to build and serve the application so that we can access it within a browser. It appears Angular's completed its work, so let's navigate over to the browser, and now we're going to access the application on our local host at port 4200. You'll notice that when accessing the application, all of the products served by the HSports catalog API are displayed on the web page. So our Angular app was able to leverage the API that we built using all of Swagger's tooling, as well as Azure and the Apogee API management platform. At this point, we have a working app and our course project is complete.